Next speaker is Liangbing Hu. He comes from the Institute of Plasma Physics Chinese Academy of Science. He's in charge of a cryogenic control system of East superconducting tomahawk. His field is about instrumentation and control for large-scale cryogenic systems, simulation and optimization of cryogenic process and control. He will give a talk on simulation of cryogenic process and control of East based on EPICS.
My topic is about simulation of cryogenic process and control of East based on EPICS. This project is developed by ASIPP and DAISY. My content including 4 parts. The first, I introduce East and East cryogenic system, then design simulator based on EPICS, and then next I give the results, and last I make simple conclusions. Maybe you know East superconducting tokamak is the experimental advanced superconducting tokamak. It is the first full superconducting fusion device in the world. So, cryogenic system is one of critical subsystems. The cryogenics to cool down the cold components, including the superconducting magnets and the support system. The total cold mass is 215 tons. This figure shows the process of East cryogenic system. The first part, the compressor stations. This part, the coldbox. This part, cryogenic distribution system. The coldbox, including the 2 refrigerator cycles with liquid nitrogen pre-cooling. The first closed cycle with 3 turbines to produce refrigerator power and 4.5 Kelvin for superconducting magnets. Another, the research Brighton cycle with 2 turbines ensures to produce refrigerating power and 18 Kelvin for servo cylinder. The total refrigerating power is about 2 kilowatt at 4.5 Kelvin. This is the cryogenic control system. The control system is based on Delta-V DCS. Delta-V DCS is a product of Emerson Company. This shows the architecture, this part, the Delta-V DCS, the cryogenic system is the oxygen system, is extra rich. Now, in some new system added in system. So new compressor and the turbine, the PLC control system is combined with DCS through Modbus and Profibus DP protocol. Cryogenic is very complex, and we require the very high reliability and stable. So the simulation is a good way to analyze the dynamic behavior. So now we want to use dynamic simulation to refrigeration process design and control strategies design, performance optimization, manage under abnormal conditions, system commissions. Currently, we faced a task. We will upgrade our control system from Delta-V DCS to operate EPICS architecture. So we need to design. We want to design the simulation architecture is based on EPICS. This shows the architecture. We want to use the EcosimPro and Cryogenic to design the process. And then we select the control system we base the EPICS. The communication is by the OPC2 core. The OPC server in the EcosimPro and the IOC part, we designed the IOC-OPC-Client. EcosimPro is a and simulation software. Can be used not of VMS into the CERN, DAISY, ASIPP, CA, and ITER. The Cryogenic is a commissioned cryogenic library which is developed and valid at CERN. Now it including all the components for the cryogenic system. So this is the warm compressor station module in the EcosimPro, and we in the base on the Cryogenic, and we design the new module for the control. This is the dynamic PID. This is the multi-process controller. This is solid vapor control. This is charge control. This is the module on the coldbox and the distribution system. In the part we just design a new heat exchange module. Finish create the module, and next we create an OPC server in EcosimPro. In the EcosimPro, there are one OPC toolbox to create the OPC server. This shows how to create the OPC server. First, we create the DAC, and then we create the OPC server. Now we create the IOC-OPC-Client. This software is software complex of IOC. In the part we need configuration records. This is the records configuration in IOC-OPC-Client. First part is the BI, and this BO, AO, and AI. This is the PRD record, and the AO for the error for a error record. And last, we need configuring the interface in CSS. This is the simple warm compressor interface. This part I give the simulation results. This is the pressure of warm compressor. You look here, the one of the compressor stop, the mass flow the stop, and then the low compressor and middle compressor and high compressor fluctuate. Okay, and last I give a conclusion and perspective too. The simulator for cryogenic process and control based on EPICS has been developed by ASIPP and DAISY. The real-time communication between cryogenic process and control system is realized by OPC protocol. The simulator is a helpful upgrade of our cryogenic control system. In the future, we will create the simulator platform to help design and applying our cryogenic system. Thanks for your attention.